Hello, this week we're going to talk to you about pipe welding. It's going to talk about joint fit up issues, the different passes we do, the root, the hot, the fill pass, the cap, all of their purposes, cleaning either before welding or after welding, all that kind of stuff. This will go along with the modules we're doing for GTAW pipe and SMAW pipe. So to backtrack a little bit to those, SMAW versus GTAW. SMAW will always be around. You can do it with very minimal equipment. It's cheap to get into, and you can do it anywhere. You can do it laying in a puddle of mud. You can do it with the wind out. It doesn't matter. You can always get it done. GTAW takes a lot more preparation and planning before you can do that on pipe on the outside. But in the shop, it's by far the preferred method. It's cleaner. It's easier to do. There's less chance of defects. It's just better. So, having said that, let's talk about joint prep first off. So, joint prep will make or break your pipe joint. If you've got the prep wrong or you've got your fit up wrong, your chance of passing that test just go through the floor. Not good. So I'm going to draw a really big part of a pipe joint. I'm going to draw it a little differently on both of them. I won't. I changed my mind. So this is one side of the pipe joint, my representation. Okay. So what are the parts of this? Well, we'll start at the top. This is called the bevel. B-E-V-E-L. The bevel. That is the bevel as well. The bevel is the angled face of the weld joint. Usually on pipe, and this varies code to code, usually it's between 30 and 40 degrees. The common number for most pipe welders is 37.5 degrees, and that's not included. What that means is this angle right here, 37.5 degrees. That's very, very common. That's what most people do, okay? But that's our bevel angle. Included, like as we're doing plate tests, our bevel angle is 22.5, so our included angle is 45. If I'm doing 37.5, my bevel angle turns into 75 degree included. So generally, 75 degrees, okay? So these are the bevels. This dimension right here is absolutely key to us, and that's our root opening, okay? Root opening, there is an acceptable range in code, but a lot of it's up to the individual welder. Pretty much every code there is will not allow you to butt the pipes up tight. You've got to have a small root opening, at least a 32nd. But beyond that, you can go in most codes up to an 8, and it's up to you. When it comes to pipe welding, a lot of the stuff is figuring out what works for you, because there's going to be a happy medium between all the different variables. And I'll talk more specifically to that point after we get done with this. So that's our root opening. I like to run with these. I like to run about 3/32 of an inch. Okay, approximately 3/32 of an inch. And this is when I'm talking about this. This is SMAW predominantly, but I actually use the same root opening for TIG. Anyway, root opening critical. Next thing is this flat surface right here. This is called the land or the landing, and that's that flat spot on the root face. Okay, and this actual landing is also called the root face. So most codes require you to have a land of some sort. Some codes do not. Some codes will allow you to give it what they call a feather edge, which is a knife edge, give you a sharp bevel. Some codes allow that, some codes don't. Some welders like that, some welders don't. I like feather edges when I'm TIG welding. I do not like them when I'm stick welding. So your mileage may vary. This is called a feather edge. Okay? So I'm going to erase a bunch of this stuff to clean up the picture, and then we'll talk. So when I talk about finding that happy medium between all these different things, that's really for me the hard part, is finding something that works for you. And I don't know how many of you are familiar with scientific method, but when we start practicing this stuff, it's really important that we don't go in and change 3 different things at once. Because at that point, you don't know which one of those made it better or worse. If I go in and my first weld looked bad, I say I set this up at 332 opening, 37.5 degree bevels, and a 16th land, and it went badly. If I go in and tighten this up to a 16th and take that down to a 32nd and close this up to 60, and it's better, well, which of those things made it better? We don't want to do that. We want to change one variable at a time and observe the result. So first thing, there's going to be a relationship between all these things and the amperage you're going to run. Okay? The tighter your root opening, generally the hotter amperage you're going to run, because you need more heat to melt through this and get complete fusion on the back of this. The bigger your root opening is, the lower amperage you run. I like to run, myself, with stick, I run a lower amperage setting and run a little bit wider root opening. If I run higher amperages and tight, it works fine right up until it gets away from me, and then I can't get it back. With the lower amperage, I have a chance to get out of that keyhole and get back and fill and have a chance at it. When my amperage is set up too high, I'm never going to get there. So that's how I run these. A little more root opening, a little lower amperage, and I really don't change my bevels much. I run 37.5 degree bevel on all my stick pipe. But you've got to find what works for you. If you're comfortable running higher ampeраges, you feel like you're in control of that keyhole, run a tighter root opening or less land. And that's the other thing too is, if I start to feel it gets away from me, I'll run a bigger land. I'll go from a 32nd, you can go, I believe, up to an 8th landing, which is huge. But those are all, as long as they're within the code, those are all specs you can run to make it work for you. So find out what works for you, and that's going to take you some time. But once you get there, stay there and just keep working out to get better. So let's talk about individual passes. So the first thing we're going to do on these, actually let's not talk about that yet. Put the cart before the horse. Let's talk about fit up issues. The biggest fit up issue you're going to get with these, as far as putting the pipes together, is what they call high-low. And what that means is that these two surfaces are not parallel with each other. You'll see pipe joints fit up. This is an exaggeration, where they're offset. The difference between that and that is a 16th to an 1/8 of an inch. That's not going to work for you, trust me. The code has values in there that you cannot have more than, usually it's a 16th of what they call high-low or offset. That will make it virtually impossible for you to put in a quality root and get fusion to both sides of it, because it will catch the side that's closer to you, will catch it and not want to go down and burn the other side. And if you get it down there to burn the other side, you're going to blow through. So high-low is really bad. And the easiest way for me to fit up pipe without an expensive piece of mounting tool, basic tool or fixture, just get a big piece of angle iron. I don't like it looks like I'm drawing a Valentine, I'm not. So get a big piece of angle iron, put your pipe pieces in here. That is not round, that's okay. And if that angle iron is long enough to span a good chunk of both of those pipes or completely have both of those pipes, so I've got an angle iron like that. I got my 2 pieces of pipe in here. I know these bottom surfaces and this top surface is probably going to be flush. And pipe's weird stuff. You look at pipe and you assume it's round. It is not round. It is almost always have a slight bit of egg shape to it. So what you also might have to do is roll those pieces around until you find the egg shapes that match each other. Hopefully it's out of the same piece of pipe. That works really well. If not, you're going to have some high-low to deal with. And what you do there is you tack the parts that are flush, and then you work the rest of it with clamps or docks and wedges or something to push or pull the pipe until you get the fit up right. Not only is that for weld tests, when you go out in the field welding pipe, you're going to be doing that too, because the inspector's going to be checking. So high-low is an absolute killer. So that's the biggest factor is high-low. The next one is inconsistencies of any kind. If your root opening is not consistent for the whole pipe joint, your settings are not going to be right for a part of that pipe joint. If you've got, if you've got the root opening you want at the bottom, but it's big at the top, you're going to be too hot at the top because you're not going to have, your root opening is going to be bigger. So you want consistency all the time. Root opening is the biggest place that it's going to be bad, and then landing is probably the next one of most importance. If your landing goes from an 1/8 to a 1/16, it's going to run vastly differently when you get there on that pipe pass. So consistency in everything. What a lot of people like to do is once they get their pipe fit up, a lot of times when you tack together with shrink, what they'll do is they'll get a 1/16" skinny wheel for their grinder and go around and plunge into that, plunge their skinny wheel in here, into the weld joint, and just go around the whole pipe, minus the tacks of course, and just to true up that face, clean it up, make sure it's consistent all the way around. So talking about tacks are a very, very important part of getting your pipe joint fit up. When we say tacks, you might think of some little button tack. A tack on a pipe joint is like 1 inch of weld. Okay, and when if I've got my pipe like this, this is going to be, to my mind, the weld is going to be cut up in quadrants. Okay, I've got 0 degrees up here, I got 180 down here, I've got 90, I got 270. Okay, so this is, you call it whatever you want, Q1, Q2, I can't draw, Q3, Q4. My tacks are not going to be in these quadrants. They're going to be up here, and here, and here, and here. And why is that? Well, it's because when I cut this up and bend it, these are my coupons that are going to get bent. I do not want my tacks anywhere near my weld coupons. I want them out of the way. I want them on the edges. So these are going to be, like I said, 1 inch of weld, and they need to be just as good as your root pass is going to be. The inside of them has to pass code just like the rest of your weld does. So your tacks have to be really good, and they're also a really good way to see if your welder's set right. When you're putting your tacks in, if it's starting to get away from you, turn your machine down 5 amps. Or if you're welding and you're having a hard time getting through and getting that good bead on the inside of the pipe, turn it up a little bit. They're a real good way to check your settings before you actually sit down and run this root. So the other thing I'm going to do is after I get my tacks in, I'm going to do what's called feathering them. And what that means is I'm going to grind parts of them out so that when I roll into them with my weld bead, I stand a much better chance of getting fusion on them. What that's going to look like if this is my pipe and my tacks right here, I'm going to come in with a grinder and I'm going to grind that out and grind that out. So that when I'm welding on this thing, coming up here and welding, and I'm forming my welding inside of the pipe, when I get up to here, I've just got a very thin sliver of metal that I'll be able to burn through easily, and then I'll be able to walk up onto my pipe and stop there. And this one, I'm coming this way. Again, I'm going to be welding along, I'm going to put a nice bead on the inside of the pipe. I'm going to have no problem welding through that tack. And I've got a root with lack or fusion the whole way, no lack of fusion in my tacks, no lack of fusion in my tines, it all works out. Those were tacks.